9.3 goes over operations with functions. The first part that we're going to be looking at today is just taking two different functions and using our addition, subtraction, multiplication, and division with those two functions. So if we look at example 1, we're going to let f of x be 4x minus 12, and g of x is going to equal x minus 3. So wherever you see f of x, you're going to replace it with the 4x minus 12. Wherever you see the g of x, you're going to replace it with the x minus 3. For example A, we are doing f plus g of x. So for this, it's the same exact thing as saying f of x plus g of x. So we said that f of x was the 4x minus 12. G of x is the x minus 3. If we combine like terms here, the 4x plus the x gives us 5x, and the negative 12 minus the 3 gives us negative 15. So f plus g of x is equal to 5x minus 15. For example B, we have f minus g of x. So again, this is the same exact thing as saying f of x minus g of x. If we're using the 4x minus 2 for f of x and the x minus 3 for g of x, this is going to give us 4x minus 12 minus x minus 3. For here, since we do have a subtraction sign in between those two parentheses, we are going to distribute that negative into the second set of parentheses. So we're going to have 4x minus 12 minus x plus 3. So f minus g of x gives us the 4x minus x, which is 3x, and the negative 12 plus 3 is negative 9. So 3x minus 9. For example C, we're going to be doing f times g of x. So again, we're just doing f of x times g of x. We said that f of x is that 4x minus 12. G of x is the x minus 3. So we just FOIL these out and multiply them. So 4x times x is 4x squared. The 4x times negative 3 is negative 12x. Negative 12 times x is negative 12x. And negative 12 times negative 3 is a positive 36. So putting this all together and combining our like terms, that f times g of x is 4x squared minus 24x plus 36. For example D, we have f divided by g of x. So we're just going to take f of x and divide it by g of x. We said that f of x is that 4x minus 12, and g of x is the x minus 3. If we factored out our greatest common factor from the numerator, it's going to give us 4 times x minus 3 over x minus 3. Now you have an x minus 3 in the numerator and the denominator, so those cancel out. And f over g of x is just equal to 4. For our next set of examples, we're still going to be using f of x as 4x minus 12 and g of x as x minus 3. The only difference now is we're replacing wherever the x is with an actual number and simplifying. So for example 2a, we have f plus g of 2. This just means that we're going to take f of 2 plus g of 2. So f of 2, we're just going to take the f of x and plug in 2 wherever we see an x. So that's going to be 4 times 2 minus 12. In that g of 2, we're going to do the same thing. Wherever we see an x, we're going to replace it with a 2. So it's going to be 2 minus 3. In your first set of brackets, the 4 times 2 gives us 8 minus 12. The 2 minus 3 gives us negative 1. The 8 minus 12 is negative 4, and negative 4 plus negative 1 gives us that f plus g of 2 is equal to negative 5. For example B, we have f plus g of negative 4. So again, we're just going to take f, plug in the negative 4 wherever we see the x, and then we'll take g, plug in the negative 4 wherever we see the x, simplify both of those expressions, and then add them. So f of negative 4, we're going to have 4 times negative 4 minus 12. G of negative 4, we're going to have negative 4 plus 3. Or sorry, negative 4 minus 3. The negative 4 times 4 gives us a negative 16 minus 12 in the first set of brackets. And the negative 4 minus 3 is a negative 7. From here, the negative 16 minus 12 gives us a negative 28. If we add the negative 7 to that, it gives us a negative 35. So f plus g of negative 4 is equal to negative 35. So we left off with example 3 yesterday. Example 3 just tells you that given that y is equal to x squared minus 2x plus 3 and z is equal to 2y minus 5, write z as a function of x, which means your function that's labeled z is equal to, you want x in that expression or in that equation, not y. So what we're going to do is wherever we see a y, we are going to take what y is equal to, which is the x squared minus 2x plus 3, and plug it in for that y. So we're going to have z is equal to 2 times x squared minus 2x plus 3 minus 5. First thing we do is distribute that 2. So we have z is equal to 2x squared minus 4x plus 6 minus 5. From here, you do have like terms of that 6 and that negative 5. So combine those, and you have z is equal to 2x squared minus 4x plus 1. For example 4, we're told to let f of x be 3x minus 2 and g of x is equal to x squared plus 2x. And we're just evaluating each of the expressions. For a, we have g of f of 3. So what this is telling us is to first plug in 3 for x wherever we see x in f of x. Then whatever we get for that answer, we plug in to g of x for x. So first, we're going to find f of 3. We have 3x minus 2, that is at f of x. So from there, we're just going to plug the 3 in for x. We're going to have f of 3 is equal to 3 times 3 minus 2. That 3 times 3 is 9, and 9 minus 2 gives us that f of 3 is equal to 7. Now that we have what f of 3 is, we're going to find g of that. So that's g of 7. So anywhere we have an x in g of x, we're going to plug in that 7. So the 7 goes in for the x and the x squared, as well as the x and the negative 2x. So g of f of 3, or g of 7, is equal to 7 squared minus 2 times 7. That 7 squared is 49. That negative 2 times 7 is negative 14. So we're going to do 49 minus 14 to get g of f of 3, which again is the same thing as g of 7. 49 minus 14 gives us 35. For example B, we have f of g of negative 4. So first we want to find that g of negative 4. So we're going to plug in negative 4 wherever we have an x in g of x. So it's going to be negative 4 squared plus 2 times negative 4. From here, that negative 4 squared is 16. The 2 times negative 4 is negative 8. So g of negative 4 is 16 minus 8, which is 8. From here, we're going to plug that in for x in f of x and find f of 8. So this is going to be 3 times 8 minus 2. The 3 times 8 gives us 24, and 24 minus 2 gives us f of g of negative 4 is equal to 22. For example C, we have g of f of 2. This little tiny open circle means of. So this is the same exact thing as saying find g of f of 2. So we're first going to find f of 2. So we're going to plug in 2 for x in f of x. So 3 times 2 minus 2. The 3 times 2 gives us 6, and 6 minus 2 gives us f of 2 is equal to 4. From here, we're going to find g of 4. So remember, g of x was that x squared minus 2x. So we have a 4 that gets plugged in. So 4 squared minus 2 times 4. The 4 squared is 16. The negative 2 times 4 is negative 8. So we have g of f of 2 is equal to 8. For example D, we have f of g of 2. So again, if you want to rewrite this to do f of g of 2 this way, you can. This is going to give us the same exact thing as finding g of 2 first. So that's going to be 2 squared minus 2 times 2. The 2 squared is 4. The negative 2 times 2 is negative 4. So g of 2 is equal to 0. If we plug in that 0 for g of 2 and find f of 0, that's going to give us 3 times 0 minus 2. Anytime 0 is 0, minus 2 gives us f of g of 2 is equal to negative 2. For example 5, we're still working with f of x is equal to 3x minus 2 and g of x is equal to x squared plus 2x. For a, we have g of f of x. So this, we're finding the same thing as saying take g of f of x. So all this means is we're taking f of x and plugging it in for x and g of x. So f of x is equal to 3x minus 2. So this is the same exact thing as saying find g of 3x minus 2. So g of x is at x squared plus 2x. If we plug this in for x wherever we see an x and simplify, we'll get the g of f of x. So g of f of x is going to equal 3x minus 2 squared plus 2 times 3x minus 2. We are going to have to FOIL here, so that 3x minus 2 squared is 3x minus 2 times 3x minus 2. And then we're also going to distribute that 2 into the 3x minus 2. So we're going to have 2 times 3x minus 2 times 2. From here, if we FOIL, 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. The negative 2 times 3x is negative 6x. And negative 2 times negative 2 is a positive 4. Multiply the 2 times 3x, that gives us 6x. Multiply the negative 2 times the negative 2. Or sorry, the negative 2 times the positive 2, that's a negative 4. Combine your like terms from here. The negative 6x minus 6x is negative 12x, plus 6x gives us negative 6x. That 9x squared didn't match with another 9x squared, so put it out front. And the negative 4 and the positive 4 are opposites, so they cancel each other out. So we have g of f of x is equal to 9x squared minus 6x. And for our last example, B, we have f of g of x. So again, if you want to rewrite this, it's the same thing as saying to take f of g of x. So we're just going to find what g of x is, which is the x squared plus 2x. So we're going to do f of x squared plus 2x, which means f of x is the 3x minus 2. We're going to take the x squared minus 2x and plug it in for x in that 3x minus 2. So we're going to do f of g of x is equal to 3 times x squared plus 2x minus 2. Distribute the 3 in. So we're going to have f of g of x is equal to 3x squared plus 6x minus 2. We do not have like terms here, so this is our answer.